All right, so what I'm going to do here in this first video is I'm going to go through the vocabulary part of section 3.3, slopes of lines. Now, in all honesty, this is Algebra 1 review. Okay, we're talking about slopes of lines. There are a couple postulates in here, but in all reality, those postulates are things that you really already know from Algebra 1. We're just now calling them postulates. Okay, all right, so I'm going to start up with the vocabulary term slope. Okay. Okay, slope is just the ratio of change along the y-axis to the change along the x-axis between any 2 points on the line. Now, again, you don't have to write all of that down, okay? But there are a couple different ways that we've always talked about slope, okay? There you see the green M. We use M to represent slope. So if you see a lowercase m like that, what should be clicking in your mind is this is talking about slope. Okay, all right, then rise over run. Rise over run is real typical, or a real typical term or phrase that's used to refer to slope. That's something I know you guys have heard before. Okay, and then you see the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, another thing you're going to hear me say, and maybe someone else has said this to you, is slope is change in y over change in x. Okay, change in y over change in x. On the graph, okay, you have a blue line on a coordinate grid here, and you see a demonstration of exactly where the rise and the run are. Okay, the rise is up and down, the run is left to right. Okay, and then you see where we get those x sub 2, y sub 2. Those are just our coordinates of any 2 points on the line. Any 2 points on the line. Okay, you don't have to get specific. Okay, it's just any 2 points on that line. Okay, now I'm going to skip that chart there. I'll come back to it. Okay, but now I want to talk about rate of change. Okay, rate of change is just another term for slope. Okay, and oftentimes we use rate of change in story problems when we have some kind of application to what our slope is representing. Okay, another term for slope. Now, this phrase right here, okay, describes how a quantity y changes in relation to a quantity x. A lot of times that quantity x is time, okay, when we're talking about rate of change. Okay, so it's usually, not all the time, but it's usually how something changes over time. Okay, it's usually how something changes over time. For example, okay, speed is a rate of change, miles per hour. Okay, how many miles are you going per hour? That is a rate of change. Okay, so big picture here, rate of change is another phrase for slope. Slope and rate of change are the same thing. Slope's kind of the nuts and bolts of it, the mechanics of it. Rate of change is what we call it when we're applying it, okay, in some kind of application problem or story problem. Okay, here you have your first postulate today. Now, I'm not going to put this on your postulate sheet just because this is something that you should know, and it's just a general knowledge thing that you need to know from here in through your other math classes, okay? Parallel lines have the same slope. Okay, that needs to be just common knowledge for you. Okay, parallel lines have the same slope. Okay, now let's change it to perpendicular. Okay, slopes of perpendicular lines postulate. Okay, again, this needs to just be common knowledge. Okay, lines are perpendicular if and only if the product of their slopes is -1. Okay, so perpendicular lines. Okay, I'm going to call this the slope of line A. Okay, and the slope of line B. Let's say the slope of line A is 2/3. If line A and line B are perpendicular, then line B will be the reciprocal, or its slope will be the reciprocal of the slope of line A. So here's, in addition to the product of their slopes being -1, you also know lines are perpendicular if their slopes are opposite reciprocals of each other. Okay, opposite meaning if one of them's positive, the other one's negative, and vice versa. And then reciprocals, you guys know what a reciprocal is. Now, let's use the postulate here, okay, and let's multiply the slopes together just to verify that their reciprocal, or I'm sorry, their product, rather, is -1. Okay, so in the numerator, 2 times -3 is -6. In the denominator, 3 times 2 is 6, -1. So two things here. The postulate says lines are perpendicular if and only if the product of their slopes is -1. What you can check for with the eye test, all right, two lines are perpendicular if their slopes are what we call opposite reciprocals. Okay. All right. Now I'm going to get away from this. Okay, I'm going to get away from this. Okay, and what I'm going to do is I'm going to go to this right here. Okay, this grid. Again, you need to have some general knowledge about when you look at a line if it has a positive or negative slope. Okay, it has a positive slope if it looks like this. Looks like we're going uphill. Okay, if I put a tiny dude on top of that, okay, he's walking left to right. Okay, he's walking left to right uphill. Okay. On the contrary, negative sloping lines look like this. Okay, so again, if I put that little dude there, what's he doing left to right? He's walking downhill, negative slope. Zero sloping lines. Okay, so here's where we get some special cases. You have zero slope if you're horizontal. Okay, horizontal lines have zero slope. Okay, so when you go to calculate the slope, which we're going to talk about here in a second, all right, you have this ratio, right? Remember the slope formula is change in y over change in x. If when you do that, your change in y's are 0 and your change in x's, you get some other number, that's going to give you horizontal slope, okay? Slope of 0. On the contrary, undefined slope, vertical lines, okay? Vertical lines have an undefined slope. So what's going to happen here, okay, when you go to use this formula right here? You're going to get a 0 in the denominator. Some kind of number, other number up there. So anytime 0 in the denominator, that's undefined. If you try to punch that out on your calculator freaks out. Okay, it's going to freak out and it's going to give you some kind of error. Okay, and that should be kind of those red flags that, hey, I have an undefined slope here. I have a vertical line.